Imagine standing on a quiet beach along the Massachusetts coastline. The Atlantic Ocean stretches endlessly before you. Fishing boats drift across calm waters. Seagulls circle overhead. The sky is clear. Nothing seems unusual. Then suddenly, a brilliant streak of light tears across the heavens. Brighter than Venus, brighter than any airplane, brighter for a few terrifying moments than almost anything else in the sky. People stop walking, drivers pull over, fishermen stare upward. Some reach for their phones, others freeze in confusion. The object races across the atmosphere at tens of thousands of miles per hour. Then comes the explosion, a flash, a burst of energy, a shock wave moving through the upper atmosphere. For a brief moment, the sky itself seems to detonate. What exactly happened? Was it a meteor, a comet fragment, space debris? And how close did Massachusetts come to disaster? This is the story of the mysterious meteor blast off the coast of Massachusetts, a reminder that Earth is not isolated in space. It is constantly being bombarded by visitors from the cosmos. Most arrive unnoticed. Some create spectacular light shows. A few change history forever. And occasionally one explodes so dramatically that it captures the attention of an entire region. To understand what happened that day, we must first understand something astonishing. Every single day, Earth is struck by material from space. Not once, not twice, thousands of times. Tiny particles constantly enter our atmosphere. Dust-sized fragments burn up harmlessly. Most never reach the ground. You could spend your entire life unaware that this cosmic bombardment is occurring above your head every moment of every day. The reason we rarely notice it is because most incoming objects are incredibly small. A grain of sand, a pebble, perhaps a small rock. When they encounter Earth's atmosphere, friction generates tremendous heat. The object glows, vaporizes, and disappears. We call these meteors, shooting stars. Beautiful, brief, harmless. But occasionally, something much larger arrives. Instead of a tiny grain of dust, it might be a rock the size of a basketball, a car, a house, or even larger. When these larger objects enter Earth's atmosphere, the consequences become far more dramatic. And this is where the Massachusetts event becomes fascinating. Witnesses described seeing an intensely bright fireball crossing the sky. Reports flooded into astronomical organizations. Some people thought it was an aircraft in distress. Others believed it might be a missile. Many simply couldn't explain what they had witnessed. The object was moving too fast, too bright, too unusual. Scientists immediately began gathering data: radar systems, satellite observations, eyewitness reports, security cameras, dash cams. Every available piece of evidence became part of the investigation. The goal was simple: determine what entered Earth's atmosphere, because not every bright object in the sky is the same. A meteor is different from a comet. A comet is different from an asteroid. An asteroid is different from space debris, and identifying the source can reveal a great deal about the event itself. The first clue came from the object's speed. Objects entering from deep space often travel at extraordinary velocities. Many move faster than bullets, much faster. A rifle bullet may travel around 1,700 miles per hour. Some meteors enter the atmosphere at over 40,000 miles per hour. Others exceed 100,000 miles per hour. At those speeds, the atmosphere behaves almost like a solid wall. Compression generates tremendous temperatures. The air itself begins to glow. The object becomes a blazing fireball, and if conditions are right or wrong, depending on your perspective, the object explodes. Scientists call this an airburst. It sounds technical, but the concept is surprisingly simple. Imagine squeezing a fragile object under immense pressure. Eventually it breaks. The same thing happens to many meteors. As they plunge deeper into the atmosphere, pressure increases dramatically. Weak points develop. Cracks spread. The object fragments. Then, suddenly, it explodes. The energy released can be astonishing. Even a relatively small space rock can produce an explosion equivalent to tons of conventional explosives. This is why meteor airbursts attract so much scientific attention. The Massachusetts fireball likely experienced exactly this process. High above the Atlantic Ocean, tremendous atmospheric pressure overwhelmed the object. The meteor fragmented. The pieces spread apart. Energy was released, and observers witnessed a spectacular celestial explosion. Fortunately, the event occurred offshore. Had it happened directly above a populated city, the experience would have been much more alarming. To understand why, we need only look at history. On the morning of June 30th, 1908, residents of a remote region of Siberia witnessed one of the most powerful impacts in recorded history. A massive explosion occurred above the Tunguska region. The blast flattened approximately 80 million trees. Forests were devastated across hundreds of square miles. Witnesses reported a fireball streaking across the sky. Windows shattered. Shock waves traveled enormous distances. Yet remarkably, no impact crater was found. The reason? The object exploded in the atmosphere before reaching the ground. An airburst. The same basic phenomenon that occurred off Massachusetts, only much larger, far larger. Then there was Chelyabinsk, Russia, February 15, 2013. A meteor approximately 60 feet across entered Earth's atmosphere. Thousands of dashboard cameras captured the event. The fireball was brighter than the sun. The resulting shock waves shattered windows throughout the city. Buildings were damaged. More than 1,000 people were injured, mostly by flying glass. Again, the object exploded in the atmosphere. Again, no major crater formed. Again, humanity received a reminder that space can be unpredictable. Compared to Tunguska or Chelyabinsk, the Massachusetts event was much smaller, but it belonged to the same family of phenomena. A cosmic visitor meeting Earth's atmosphere with explosive results. What makes events like these so captivating is their unpredictability. Scientists monitor thousands of asteroids. Powerful telescopes scan the skies every night. Space agencies track potentially hazardous objects. Yet many smaller meteors remain invisible until the moment they arrive. Why? Because they are tiny compared to astronomical distances. Imagine trying to spot a grain of sand floating hundreds of miles away. That is essentially the challenge astronomers face. The universe is vast, objects are dark, detection is difficult. As a result, many meteors are discovered only after they enter Earth's atmosphere. The Massachusetts fireball serves as a perfect example. One moment, nobody knew it existed. Minutes later, thousands of people were discussing it. News stations reported on it. Astronomers analyzed it. Social media exploded with videos and eyewitness accounts. For a brief period, an object that had traveled millions of miles through space became one of the most talked about events in the region. And perhaps the most astonishing aspect of all is where these objects come from. Some originate in the asteroid belt between Mars and Jupiter, a region containing countless rocky bodies orbiting the sun. Occasionally, collisions occur, fragments break away, gravity alters trajectories. A piece begins a long journey through the solar system, perhaps for millions of years. Eventually, Earth's orbit intersects its path. The result? A fireball over Massachusetts. Other objects may come from comets, ancient icy travelers from the outer solar system. As they approach the sun, pieces can break away. These fragments continue traveling through space long after the parent comet has moved on. Some eventually encounter Earth. The sky flashes. Another meteor is born. Think about that for a moment. The object witnessed off Massachusetts may have spent millions of years wandering through space. It may have formed before humans existed, before civilizations, before written language, before history itself. Then, after an unimaginable journey, it ended its existence in a fraction of a second. A bright streak, an explosion, and then nothing. Gone forever. There is something profoundly humbling about that. Human beings often view Earth as the center of their experience. Our cities, our nations, our problems, our lives. Yet events like this remind us that we are part of a much larger story, a cosmic story, one involving planets, asteroids, comets, stars, galaxies, and forces operating on scales difficult to comprehend. The meteor over Massachusetts was not attacking Earth. It was not targeting anyone. It was simply following the laws of physics, a small fragment of the solar system intersecting our atmosphere, a random encounter in an enormous universe. And despite the danger these objects can sometimes pose, they also provide scientists with extraordinary opportunities. Meteor fragments reveal information about the early solar system. Some contain materials older than Earth itself. They act as time capsules, messages from the dawn of planetary formation. By studying meteorites, researchers learn how planets formed, how water may have arrived on Earth, how the building blocks of life were distributed throughout the solar system. In other words, meteors are not merely threats. They are clues. Clues about our origins. Clues about our place in the universe. Clues about a past stretching back billions of years. That is why every major meteor event attracts scientific interest. Researchers are not simply asking what exploded. They are asking, what can this teach us? And in many cases, the answers are remarkable. The Massachusetts fireball may not have caused destruction. It may not have left a crater. It may not have altered history, but it achieved something important. It reminded people to look up, to remember that the sky is not empty, that Earth's atmosphere serves as a shield protecting us from countless cosmic visitors. That extraordinary events can occur without warning, and that even in the modern age, the universe still possesses the power to surprise us. Perhaps somewhere tonight, another meteor is already approaching. Invisible, silent, traveling through darkness. No headlines, no warnings, no audience. Until suddenly, somewhere over an ocean, a desert, or a city, the sky erupts with light. Another brief encounter between Earth and the cosmos. Another reminder of how dynamic our universe truly is. The meteor blast off the coast of Massachusetts lasted only moments. Yet those moments connected thousands of people to something far larger than themselves. A journey through space, a collision with our atmosphere, an explosion witnessed from below, a fleeting event, but one that revealed the extraordinary forces operating above our heads every single day. And perhaps that is the most remarkable lesson of all. The universe is not distant. It is not separate from us. It is happening all around us. Every night, every day, every moment. And sometimes, if we're lucky enough to look up at the right time, we get a front row seat to one of its greatest spectacles. If you enjoyed this documentary, let us know in the comments. If you saw a giant fireball explode across the sky, what would be your first thought? A meteor, a UFO, or something else entirely? Don't forget to like, subscribe, and turn on notifications for more incredible stories from space, history, science, and the mysteries of our universe.